Hello there, we're going to be looking at section 3.3 and talking about how gases behave for this flip lesson. What type of measurements are useful? So when you work with gas, you want to make sure you understand its volume, its temperature, and its pressure, because all of those are variables that can affect gases and how they behave. So how are they all related? So think of pressure of a gas, it's the force of its outward push divided by the area of the walls of the container. So think of a basketball. It's high pressure if it's filled up and you've got all of those gas molecules bouncing around. And then low pressure as they escape. There's still air in there, it's just that it's escaping, so there's a low number of particles per unit volume inside a deflated basketball versus a filled up basketball. You need to understand that when the temperature of a gas increases at a constant pressure, its volume increases. So it's important to have all those variables in place. It has, if we are looking at the picture here on the left, it's a lower temperature, smaller volume. That's why it's represented with blue here, meaning that it's cold. But if we were to heat that up somehow on a hot plate, then those gas molecules are going to expand. And at a higher temperature, we would experience a higher or greater volume. It's like putting a balloon in a car. It's going to expand as it's in a hot car. And it would freeze if we put it inside of a freezer. The molecules would get closer together and the balloon would decrease in size. So when a gas is heated, the particles move faster and collide more often, and they bounce and hit the walls of their container. So that's what's creating the pressure of the gas. It's greater when we're heating it up. And when it's cooler, we don't have as much pressure pushing on the container. So Charles' law states that if we have a constant pressure, the volume of the gas increases as its temperature increases. And also, as the volume of the gas decreases, the temperature decreases. So they both either increase or they both decrease if we're talking about Charles' law, and that's temperature and volume. And the graph, if we were to do a lab and collect the data for it, the graph would be what's called directly proportional. So that means it's going to create a straight line passing through the origin. And it just means as the temperature increases, the volume's going to increase. And as weights are added, the gas particles occupy a smaller volume. Think about pushing on a balloon together. You can decrease the size. But the pressure is going to increase. So less pressure with the greatest volume. If we increase the pressure, we're going to decrease the volume, and even more pressure there in the third picture, we're going to create something that has less volume. So Boyle's law states that at a constant temperature, so we're not changing temperature here, the volume of a gas is going to increase if its pressure decreases. So these are opposites of each other. If I have a small amount of pressure, and you can think of the weight as pressure, then we're going to have a large volume. But if I have a large amount of pressure here, I'm going to have a smaller volume. And its graph is what we call inversely proportional. It has this arch here. So because the two variables are opposites, as one increases, as the pressure increases here, the volume is going to decrease. And that's the end of the section with gases. So now go ahead and go to the Google form that's listed here and answer the 3 questions on it. Please make sure you're logged into the Pleasanton account in order to access this form, and to check the box if you'd like a receipt of your answers.